Alright, in this video I'm going to talk about what is commonly referred to as the triangle inequality. And I'm going to explain it by means of a real-world example, because I feel like this is something that gets more confusing than it needs to be. Alright, so here's my example. Bernie and Hillary begin at Monticello High School. Bernie walks 4 miles, Hillary walks 3 miles. So 2 questions. What is the farthest apart Hillary and Bernie can be after their walks? What is the closest Hillary and Bernie can be after their walks? Well, if you think about this, right, we've got Hillary and Bernie. Hillary and Bernie, right? And they're both walking. One walks 4, one walks 3. What we don't know in this description is, from the description, is what directions they walk in. And we can think of a lot of different possibilities, right? This could be Hillary goes here, and Bernie goes maybe in this direction. Bernie walking farther away from each other. Then the distance between them is going to be from here to here. It's fairly long, right? And we could also imagine, on the other hand, that they go in fairly similar directions. Hillary goes this way, right? And Bernie maybe goes in just a little bit northeast, I guess. In that case, the distance between where they end up, here's Bernie, here's Hillary, is going to be a little bit shorter. Okay. You start to think about this, you can play with this. Sometimes this is called the hinge theorem, because we can imagine that this, say, Hillary is one side and Bernie is the other, and Bernie is kind of on a hinge. We can sort of open up this angle more and more so that this gets bigger and bigger. Well, what you start to realize is that there's 2 cases here. There's 2 important cases. One is the case where they go in completely opposite directions. So here's Hillary, here's Bernie. No significance in the fact that Bernie is going to the left and Hillary is going to the right. Right, so this is 3, this is 4. There's this case. That's going to be the farthest apart they could be. Right? It can't get any farther than that. Is that they just walk in opposite directions, and the total distance between them is going to be 7, right? So, right, I get that because 4 plus 3 equals 7. So the farthest apart they could be is 7 miles. The other thing you realize is that, again, thinking about this as a hinge, if I pull the hinge all the way over, I pull Bernie all the way over so they're going exactly the same direction, well, what's going to happen? Okay, so here's Hillary, and here's Bernie. He's going the same direction, he just goes a little bit farther. Okay, well, if this is 3, and this is 4, right? Now we've closed the distance between them. This is the least far apart they could be. And if you play with this sort of hinge idea, you'll see that. All right, how far apart are they now? Well, Bernie went 4, Hillary went 3 on that same line, same direction. So they are going to be 4 minus 3 equals 1 mile apart. And that will be the closest they can be. All right, so we get the farthest distance is going to be by adding together. The closest distance is going to be by subtracting one from the other, the smaller one from the bigger one, so that we get a positive number. Okay, and these up here, these scenarios up here, we could draw infinitely many other ones, are going to represent all the possibilities in between, right? Each one of these is going to be somewhere between 7 and 1, right? 7 being the longest, 1 being the shortest. Now, if we want to express those distances in inequality, let's let D equal the distance between Hillary and Bernie. Then we could say, well, that distance, D, it's going to be less than or equal to 7. Right? That's the farthest it could be. We saw that over here. And it's going to be greater than or equal to 1. So this is usually how we write it. This is just a way of expressing 2 different inequalities, basically, that D is less than or equal to 7, D is greater than or equal to 1. Well, we can write it as one statement here, like this. 1 is less than or equal to D is less than or equal to 7. Or D is between 1 and 7, including 1 and 7. All right, so that's the triangle inequality explained without triangles. Now, what does this have to do with triangles? Well, suppose we're given this problem instead. Two sides of a triangle are 3 miles and 4 miles. What is the range of possible lengths of the third side? Okay, so we've got a triangle. Well, one side is 4, the other side is 3, and this third side is what we're looking for. Well, if you think about it, this is exactly the same problem that we saw with Hillary and Bernie, right? Here's Bernie's walk is 4, Hillary's walk is 3, and now we have a triangle, and the third side of that triangle is the distance between Hillary and Bernie at the end of their walks. Okay, so we saw we could have many different kinds of triangles, right? Here's one where Hillary goes this way, and Bernie goes this way, okay, and then we got our third side. The bigger we make this angle, right, the more we open this up, the farther apart they're going to be. So here's 3 and 4, here's an even bigger triangle, okay? That third side gets bigger and bigger. Now, so we know that the biggest was what we figured out was the biggest was when we put them in opposite directions, completely opposite directions, so 3 and 4. But notice something about this with triangles that's different from the case with Bernie and Hillary. If Bernie and Hillary walk in opposite directions, that's fine. They're 7 miles apart. If I draw a triangle with sides 3 and 4 going in opposite directions, then I have a triangle anymore. Right? I've just got a segment that's 7 units long, or 7 miles long in this case. But I don't have a triangle. So in order to have a triangle, this angle here has got to be something less than 180 degrees, right? Because 3 angles in a triangle, I have to add up to 180 degrees. And this has got to be, so it's got to be less than 180 to leave something for the other 2 angles. Okay, so it couldn't quite be 180. It couldn't quite be 180 degrees, which means that the length of the third side could not quite be 7. It could be something slightly less than 7. Similarly, we found with Bernie and Hillary, we could have them walking in the same direction, right? And in which case the distance between them would be 1. But I can't have a triangle where these things are on the same line. Again, I just end up with a segment that would, in this case, be 4 units long. So I need to make this angle here, the angle between the side that's 4 and the side that's 3, be something more than 0. Right now, it's just 0 on top of each other. So it's got to be maybe, to make it really small, like this, 4 and 3. And then my third side is right here. It's not very big. That means then when we express the range of values, the possible lengths of the side here, the third side, we have to do it like this. Instead of saying 1 is that D is less than or equal to 7 and greater than or equal to 7, we have to say D is less than 7, not equal to 7, and greater than 1, but not equal to 1. If it was equal to 7, we'd have this case where we don't really have a triangle. If it was equal to 1, we'd have this case where we don't have a triangle. So it's got to be something less than 7 and something greater than 1. But this is how we would express the possible lengths of the third side of that triangle. All right, in the next video, I'll do some examples, or you'll see how this works a little bit better. But that's the basic idea.